So we want to find the absolute maximum of the function 3x to the power minus 26x cubed plus 6x squared minus 11 on the interval from -1 to 5. So the procedure is always the same. In order to find the absolute maximum, first, you're going to have to find f prime so that you can find the critical numbers. The reason why is because the absolute extrema, max or min, only occurs on two places if you are working on a closed interval, either at the critical numbers or at the endpoint of the given interval. So we're going to find the critical numbers. So the first thing we do is we take the derivative. So this is just using the simple power rule. The derivative of x to the fourth is 4x cubed times 3. That's what I get, 12. The derivative of x cubed is 3x squared. Keep the negative, negative 26 times in by 3. You get 78 times x squared. The derivative of 60x squared is 60 times the derivative of x squared, or in other words, 60 times 2x, which is 120x, and the derivative of a constant, which what negative 11 is 0. So to find the critical numbers, we need to do two things. First thing is see where the derivative equals 0. Why? Because the critical numbers only happen in two places. Where you have a horizontal tangent line, that's where the derivative is 0. That's the slope of a horizontal line is 0, and we know that the slope of the tangent line is the derivative of the function at the point. And also where you have sharp turn, discontinuity, or some kind of problem with the derivative. So the first thing we do is we're going to solve f prime of x equals 0. So we already find f prime of x, so we're going to set it equals to 0, and to do that, this is a polynomial, we're going to factor, and we can see 6 is a factor of 12, negative 78, and 120, and x is also a common factor. So a factor of 6x, 6x goes into 12x cubed, 2 times x squared minus 2. If you factor 6x out of negative 78x squared, you get negative 13x, and if you factor 6x as out of 120x, you get a 20. So we have a product equals 0, but we can see that we can, that means either this first expression is 0, so 6x is 0, that means x is 0, or that means that 2x squared minus 13x plus 20 equals 0. This is a quadratic function that actually maybe can be factored, so we're going to see that. So this is the AC method. We need to find two numbers that multiply to 2 times 20, which is 40, and add up to minus 13. Those numbers are negative 5 and negative 4. And so because the leading coefficient is 2, so remember this is a shortcut method, we found that the two numbers that satisfy such that the product is 40 and the sum is negative 13. Those numbers are negative 8 and negative 5. And then we put a 2 in front of the x's because the leading coefficient here is 2. And then remember here the last step is to reduce. I cannot reduce 2x minus 5, but I certainly can reduce this by 2. And so here we get x, this is the same thing as x minus 4. So if you reduce it, this is x minus 4. The other one cannot be reduced, so that gives us x equals 4, and this is 0. That means, so this one is 0, right? That means that 2x equals 5, which means that x equals 5/2. So we found the two critical numbers where we have a horizontal tangent line. The two critical numbers are x equals 4 and x equals 5/2. The next step is to find, let me erase that, is to find where the derivative does not exist. Oh, I meant this one, I meant f prime, sorry, but that is a typo here. It should be f prime of x, no g prime. So I don't know why I named it the wrong way. So this is f prime All right, and so, but what we can see is that the derivative is a polynomial function, just powers of x, it's f prime. So it's defined everywhere. So there's no x's where the function, again, I meant f prime here, not g prime, where the function f prime is not defined. So there's no other critical numbers. So the only two critical numbers we have, so again, this is f prime, sorry about that, and this is also f prime. The only critical numbers you have are the one where you have a horizontal tangent tangent line, which are x equals 4 and x equals 5/2. And then once you find the critical numbers, again, we only find 0, 4, and 5/2. And then we're going to check the value of the function at those critical numbers, as well at the endpoints, because again, the absolute maxima or minima only happen in two locations: the endpoint of a given interval or the critical number. So I'm just checking when x is 0, plug it in, you get -11. When x equals 5/2, so I replace x here by 5/2 in there, and then you get about 74.9375. So just plug in your calculator. So here I evaluated this function at 0, at 5/2, at 4, so I plug in 4 in for x in my calculator, and I find f of 4 is 53. And then finally, we look at the endpoint of the interval. So right here at -1 and at 5. At x equals -1, again, you can see this is 3 plus 26 plus 60 minus 11, you get 78. And then if you plug x equals 5 into your function here, you're going to get f of 5 is 114. So the only thing I did here is to plug in the critical numbers, which were 0, 4, and 5/2, as well as the endpoints, which are x equals -1 and x equals 5, into the function. And then we are left with just concluding, what does that mean? Whatever is the highest value of the function on that interval is going to be your absolute maximum. So we look at all the values we have here. The highest one is 114. So the absolute maximum is 114, and it happens at x equals 5. If I had asked for the absolute minimum, well, the lowest value of the function is -11. So that would be your absolute minimum, and it happens when x equals 5. So you see here the absolute max at the interval, but the absolute minimum happens at one of the critical points. And you can see by the graph here, so I graphed the function f on the interval from -1 to 5. You see that this is your max. And that's what we found, right? Remember, it was 114, I think, but it happens at 5, and this is your absolute minimum, and it was happened at x equals 0, and the value was -11. And you see here our critical numbers. Remember, let's just check it out. There were 3 of them, and they were at 0, 5/2, and 4. And you can see right there at 0, right here, at 4, and at 5/2, we have a horizontal tangent line. And you see there's no kink, no sharp turn or anything. So here that means that really there are only those 3 critical numbers for this function.